Hello. You have learned the technique of completing the square, and now it's time to go through some applications. But I will do this really briefly because of the time constraint. So let's start. Plotting quadratic functions, problem number 1. So here is the plan. First, I will show you how to plot the graph of a very simple second-degree function, y is equal to x squared. Then what is happening if we multiply this x squared by some coefficient. Then how to transform the graph of this simple function by finding the new vertex, and here at this point you will use the completing the square technique, and I will illustrate it with some examples which are together forming problem number 1 in this section. So first, how to plot the graph of y is equal to x squared? Well, you know that to plot such a graph you need some points, and in this case you know that the graph will be a kind of such a line which is called parabola. You have seen this at school, so it is enough to find some points in which it is easy to compute the value and just plot their coordinates, like for example here. The value in -3 is equal to -3 all squared. It is -3 times -3 is +9. So you mark the point with coordinates -3, 9, and then you do another point and some other points, and you draw this line. Then, if you get a coefficient next to x squared, what is happening then? Well, you get a bunch of parabolas which are sometimes more narrow, sometimes more broad. Like for example this one here, this green line is the parabola y is equal to x squared, which we have already discussed. So you see that this parabola, this blue one, is more narrow, exactly as the line y is equal to 2x is like more steep than the line y is equal to x. And this red one is even more narrow here, and this is represented by the equation y is equal to 4x squared. So this happens when the coefficient c is larger than 1. You get more narrow parabolas. And when the coefficient is smaller than 1 but still positive, you get broader parabolas. You can also simply verify it by putting in some x values in the formula. Like for example, when x is equal to 2, then you get 1/2 of 4, it is 2. So the point 2, 2 belongs to this orange parabola, while in the green one you had the point 2, 4. So you get a more narrow parabola. And here for this one you have the coefficient c equal to 1/10. And this point here, the lowest point on the parabola, is called vertex. And what happens if our coefficient c is negative? Well, you simply mirror the entire situation in the x-axis. So you will get here the parabola for c equal to -4, -2, and so on and so on. Okay, so this we already know, and now the most interesting part. How to transform the graph of this parabola by finding the new vertex. And then if I happen to have some coefficient c here which is different from 1, then I would first have to produce such a parabola according to the method discussed in the second point, and then proceed to finding the new vertex. Let's look at the first example. Here is our standard parabola, y is equal to x squared. And now let's say that I want to plot parabola y is equal to x squared -4. Well, this is simple. You simply move this entire curve 4 steps down. So it's a kind of translation. You move this entire line 4 steps down. Then, if this number here, in the previous slide, I simply subtracted 4 from the y value. But what happens if I subtract, let's say, 1 from the x value, from the argument? Well, then I have to move my parabola one step to the right. Why so? Well, think about this. This new function, this new parabola, gets the same value in x equal to 1 as the old one got for x equal to 0. So this is why I have to move this parabola one step to the right when I have minus sign. And by the way, by now you know that this is x squared minus 2x plus 1, right? But think about it, if you got this equation in this form, it would be difficult for you to know that you just have to move this parabola one step to the right. But in this form, it is quite easy reasoning about how do you have to move the vertex. Well, you have to move the vertex one step to the right. Here you wouldn't be able to say, so now I hope that you see the advantage of completing the square. The next example, if I take y equal to x plus 2 all squared, by the same reasoning, I find the new vertex here, 2 steps to the left. Because here the new function has the same value in minus 2 as the old had in 0. And again, in the developed form, it would be this equation, right? But from this form, it would be difficult, or at least more difficult, to plot this new line. And in this form, I simply know that I have to move the situation 2 steps to the left. And now, an even more interesting example. If you have a combination of 2 movements, 1 to the 3 steps to the left and 5 steps down. You see, 3 to the left, 5 down. In the developed form, this would be x squared plus 6x plus 9 minus 5 is 4. If you see this equation in this form, it would be really difficult to know that this parabola looks like this. But if you have this in this form, you see at once that the new vertex must have coordinates minus 3 minus 5. You can also see this on this equation. You see, this expression here is non-negative. It can be 0, but it will never ever be negative. So the smallest value for this function will be when this expression is 0. Then we get value minus 5. So the least y value is minus 5. And this happens when this expression is equal to 0, and this expression is equal to 0 for x equal to minus 3. So after completing the square, you can say really a lot about the appearance of your parabola. In this form, it's much more difficult. So now we proceed to problem number 1, but actually we have already solved the 5 parts of the problem, and now it's just one more left. And this is one which we already have completed. We have already completed the square for this one in some earlier videos. So you have already been through this computation. And we see that this expression is equal to this one. So in this way we know that our new vertex will be in the point minus 3 minus 49. So we have to move the parabola y is equal to x squared to the new vertex here. And more about this kind of transformations of graphs is discussed in this course, so you are welcome to look at this one if you want to. And this slide comes from computations and reasoning which I performed in video number 90 in this course. Thank you for watching. Bye bye.